So given this problem statement, so it says that if the sum of all possible solutions of the equation that is given as, this is the equation, right, that is log of base 2x plus 3, and in the argument we are having 6x square plus 23x plus 21, that is equal to 4 minus log of base 3x plus 7, and in the argument 4x square plus 12x plus 9, this is equal to k, that is the sum of all possible solutions for this given equation is k. So in that case we need to compute the value of minus 24 times k, that is negative 24 times k. So let us proceed towards the solution part. So first of all I'll just replicate the equation as it is, and if you can observe here clearly, this quadratic factor, that is 6x square plus 23x plus 21, this can be decomposed into linear factors, and this can be written as here 3x plus 7 and here 2x plus 3, and the other one, in this one I can write 2x plus 3 squared. So this is 2x plus 3 times 2x plus 3, right? Now in this case I can apply the logarithmic property which says that the product in the argument can be converted to sum, right? So I'll replicate this one, and here we are having log 2x plus 3, right? So in this case, this 2x plus 3 I can take it here, that is in the argument of this one, this 2x plus 3 can be written here, and this converts to sum, and again this log base 2x plus 3 I'll mention here, and this 2x plus 3 is something that I can eliminate from here. So this eventually boils down to 1. Similarly for this one, so if you observe here, we are having 3x plus 7 in the base, but this argument does not matches, right? So this is essentially squared here, right? So this is squared over here. So from this we can use the property of log, that whenever in the argument we are having an exponent, then this 2 can be written in front of this one, right? So here the power turns out to 1. Now in the next step, so instead of this one I can write 1, considering that the base, that is the argument on the base, follows the property of log, right? So now I will be using the substitution mechanism in order to simplify this. So I will make an assumption, let us say that this quantity, that is log of 3x plus 7 base 2x plus 3, this is equal to z. So if this is z, then from this we can clearly observe that this part will be 1 by z, right? So this further implies that 1 over z would be log of 2x plus 3 in the argument and in the base 3x plus 7, right? Now I can make the necessary replacements here, right? So here instead of this I can mention z over here, and this one as 1, that is 2 times 1 over z, so that is effectively 2 over z. Now on resolving this equation I would get a quadratic equation as z square minus 3z plus 2, that is equal to 0. So from this the acceptable value of z will be, if I factorize this, this is z minus 1 and this would be z minus 2, and that is equal to 0. So we can clearly observe that z belongs to the set, so it can take the value 1 and 2. Now we need to check whether these values are satisfied within the logarithmic factor or not, right? So here z equal to 1, right? So for this case I'll check, so I'll check the cases one by one. So when my z is equal to 1, I'll check with this part, right? So from this one we can clearly mention, that when z is equal to 1, so instead of z, so this is given as it is, and now instead of z I will be replacing this one by this factor, right? That is log of 3x plus 7, that is equal to 1. So from this we can clearly observe that if I resolve this, right, that is 3x plus 7 is equal to 2x plus 3, and from this we can clearly say that x is taking the value negative 4. Now we need to also check this thing, the base of this logarithm, that is 2x plus 3, this has to be greater than 0, right? So Also, this constraint we need to follow, that 2x plus 3 has to be greater than 0. So from this, from this we can clearly say that x has to be strictly greater than 3 over 2. So in this case we can say, so in this case we can clearly observe that x equal to negative 4, this quantity has to be rejected, this has to be rejected. Okay, so that was the story when z is equal to 1. Now let us check for this one, when my z value is equal to 2, right? So in that case this value is given as 2, so I'll put this one, and in the next step I'll replace this. So here z is definitely 2, so take this equation and here I'll write 2. Now let us resolve this one. So from this we can clearly observe that this 3x plus 7 is equal to 2x plus 3 and here squared over here, right? So this logarithmic form converted into exponential form, and this is clearly a quadratic equation. On solving this we will be getting that these are the acceptable values, that is negative 2 and then negative 1 over 4, right? Now we know the constraint, we know this constraint, right? So from this one, what would be the acceptable value, right? So from this we can say that x, that is x equal to negative 1 by 4, negative 1 over 4. So this is something that can be accepted, but this negative 2 cannot be accepted, because if you check for negative 2 with this particular inequation, it won't satisfy that, right? So therefore this negative 1 by 4 is the only acceptable value for k, right? Now I'll need to compute this one, that is negative 24 times k. So finally we can say, so we can say that, we can say therefore negative 24 times k would be, so this k I'll replace it with negative 1 over 4. Now on resolving this we would get 6 as the answer, right? So 6 is the answer for this particular problem statement.